Hello class, this is a video lecture part B for chapter 4, Corporate Finance, Accounting 350. So present value of an annuity, an ordinary annuity, PVA in equals the present value of an annuity with in payments. In means the number of payments. Each payment is discounted and the sum of the discounted payments is the present value of the annuity. So here's the cash flow solution. What is the present value of a 3-year $400 ordinary annuity if our interest is 5%? So future value of the value of each future value amount today. So we start from 3 years, the $400 and work backwards. Notice how this is 1 divided by our interest rate, 1 plus our interest rate to the third, to the second, to the first power. And this is the values we are getting over here on the left. So year 1 will be $380.95, $362.81, $345.54. So the present value of the ordinary annuity is going to be $1,089.30. Okay. And here's the equation solution. So again, this is 1, and it'll go all the way for 3 years, and then the payment, the in value summation time equals 1, and then down here it's our payment 1 minus 1 over our growth rate to the n power, all that divided by our interest rate. So 400 times all of this in the bracket, 1 minus 1 over 1.05 to the third power divided by 0.05. Okay, so 400 times 2.723248 gives us $1,089.30. So on your calculator, you will go in value is 3, your interest per year is 5%. So what we're trying to calculate is our present value. So our payment of 400, future value of 0. So whenever we calculate it, we'll get $1,089.30. Okay. Present value of an annuity due, PVA due to the end. So again, this one we're working backwards. And it's going to be 1 over our growth rate squared to the first. But keep in mind, this is where we go and multiply it by 1.05, our growth rate, in each of these examples. So when we do from year 2, so 400 times our 1 over our growth rate squared times our growth rate, we get 362.81. And then year 1, 400 times our 1 divided by our growth rate to the first power times our growth rate, we get 380.95. And then in year 0, 400 times 1 over our growth rate to the first power times our growth rate again, so we get 400. Okay, so total is $1,143.76. So here's the equation. Again, here's that multiplied by our growth rate. And then we already looked at this, but this is where we look at our growth rate. I'll multiply it by our growth rate. So 400 times 1 minus 1 over 1.05 to the third divided by our interest rate times our growth rate. When we get all of that and we do the calculations, we'll get 1143.76. Again, here's our calculator. N is 3, interest per year is 5%, present value is our question, that's what we're trying to solve for. So our payment is minus 400, so begin 0 as a future value, and then we'll get 1143.76. perpetuities, PVP, streams of equal payments that are expected to go on forever. Our PVP equals the payment of 1 over our interest rate, which equals our payments over our interest rate. So if you were to just multiply this straight across your basic algebra, payment over 1 times 1 over r, that's how we get this PMT divided by our interest rate. So in year 1, 100 divided by 0.5, we get 2,000, and our in 2 will be 100 divided by 10%, we get 1,000. Okay. Present value of an uneven cash flow. Stream-PVC cash flow, CF is cash flow to the end. Again, we're looking backwards now. Okay, because we're looking at a present value of a cash flow stream. Notice how the payments are 250, 300, 400. Okay, so then this will be 1 over our growth rate times 400 give us 380.95. 1 over our growth rate squared times 300 gives us 72.11. 1 over our growth rate to the third power times 250 gives us 215. So total will be 869 and 2 cents. And here's the equation. I know this looks really confusing, but it really, if you look at it mathematically, it kind of just shows what happens. So the sum of our n t minus t equals 1 over cash flow to the t, which is our time. Okay. And so here's how we get it. It's 1 over 1 plus our interest rate to the t, or number of payments, or time, months, or years. So here's the equation of what it looks like expanded. And it definitely is a lot of work if you have to use the equation. Yes, there's a lot of mathematics in there, a lot of algebra. So whenever we do it, we get 869 and 2 cents. So our present value of cash flow to the end financial calculator solution. So input in CF register, CF0 equals 0, CF1 equals 400, this is year 1, year 2 300, year 3 250. Enter I for interest, then press net present value. NPV is net present value. Button to get your NPV equals minus 869 and 2 cents. Comparisons of future value with present value. Future value contains interest, whereas present value does not. Okay, if it's today, it doesn't equal. You don't put your interest into it, which is what that's saying. At an opportunity cost rate of 10%, a lump sum payment of $700 today is the same as a lump sum payment of $931.70 in 3 years. The present value of $700 has no interest. The future value of $931.70 contains 3 years of interest, which equals $231.70. Okay. Again, comparisons of future value with present value. So here we go. Our interest is 10%. Present value of 700. There's no interest. Our future value is 770. Year 1. Year 2 is 847. Year 2 is, or year 3 is going to be 931.70, because you're gaining interest from year to year. Interest on 770 gives us this. Interest on 847 at 10% gives us this value. The values given under the tick marks for each year differ only because they contain different amounts of interest. Solving for interest rate R, suppose you pay $78.35 for an investment that promises to pay you $100 5 years from today. What annual rate of return will you earn on your investment? So that's the question. So our present value is minus $78.35. So a lot of times this is the part that confuses people when you have to enter a negative $78.35. And your future value in 5 years is going to be $100. So that's what we're looking at. We're trying to get at this point, what is that interest rate going to be if we want to grow it or to see what it is today. Okay, so with our calculator, our input is going to be 5% interest per year. We don't know that. Our present value is going to be minus $78.35, 0 payments, and then our future value will be $100. Okay, so then it'll give us 5% interest per year. Solving for time. Again, if you really think about it, this is all just basic algebra because you're solving for a specific value. A security that costs $68.30 will provide a return of 10% per year. If you want to keep the investment until it grows to a value of $100, how long will you have to keep it? Okay, so that's what we're looking at. So n minus 1, n equals question. So our present value is $68.30. So we want to grow it to $100. So that's what we're trying to figure out. Okay, so what is that going to be? So on our calculator, our n, we don't know it. Interest is 10%. Our present value is going to be minus $68.30. And our future value is going to be 100, and our payments are going to be 0. So when we put that in and we're solving for n, we'll get 4.0. So years, it'll take 4 years to get to that amount, starting at $68. Semiannual and other compounding periods. Annual compounding is a process of determining the future value of a cash flow or series of cash flows when interest is earned or added once per year. Semiannual compounding is a process of determining the future value of a cash flow or series of cash flows when interest is added twice per year. Typically, though, it's actually monthly, okay? So keep that in mind whenever you look at financing anything. Future value of a lump sum. The future value of a lump sum be larger if interest is compounded more often, holding the stated R constant or interest constant. Why is that? Because if compounding is more frequent than once per year, for example, semi-annually, quarterly, or daily, interest is earned on interest that is compounded more often. I know a lot of times people say that if you have investments, you're using compound interest to earn money. Okay, compared to annual compounding, a greater amount of interest is earned when interest is compounded more than once per year. Okay, distinguishing between different interest rates. R simple is simple quoted rate used to compute the interest paid per period. Okay, APR is annual percentage rate, which is equal to R simple. R year effective annual rate, the annual rate of interest actually being earned. Okay, so comparison of different types of interest rates are simple, written into contracts quoted by banks and brokers, not used in calculations or shown on timelines. Our period interest rate per period, example per year, per month, etc., using calculations shown on timelines. Our year used to compare returns on investments with different payments per year. So simple or the quoted rate, R simple is stated in contracts, periods per year, or M must have also be given. M means month. Examples, 8% compounded quarterly, 8% compounded daily, 365 days. Okay. If you remember in accounting, whenever interest is earned, remember whenever they say in 14, or if you get a discount whenever you're looking at inventory, remember it's 14 days. If you pay within 14 days from accounting, intro to financial or financial accounting, that's compounded. It's not compounded, but then you get a discount if you pay within 14 days. Periodic rate, R period. Periodic rate equals R per equals R simple divided by M, meaning M is month, where M is number of compounding periods per year. M equal 4 for quarterly compounds, 12 for monthly compounding, and so forth. Example, 8% compounded quarterly, R pure equals 8% divided by 4 is 2%, 8% compounded monthly, R per equals 8% divided by 12, or 0.667%. Okay. Effective annual rate, the annual rate that causes present value to grow to the same future value as it would with multiple period compounding. So effective annual rate year equals R year equals 1 plus R simple divided by number of periods to the m power, to the number of periods as well, minus 1. So 1 plus R per to the m minus 1.0. Okay, so that's what it would look like. Compounding R year, what is the effective annual rate year for an investment that pays 12% interest compounded monthly? So here's what it would look like. 12% divided by 12 months to the 12 minus 1. So our growth rate to the 12 minus 1. So it'll be 0.1268 or 12.68%. Remember, move the decimal over 2 spots to get 12.68%. Amortized loans. Amortized loan, a loan that is repaid in equal payments over its life. This is usually a good example of this is your car payments, or if you finance a car or truck. A portion of the payment represents interest and the remainder represents repayment of the amount that was borrowed. Amortization schedule are widely used for home mortgages, auto loans, and so forth to determine how much of each payment represents principal repayment and how much represents interest. Again, if you have an amortization table or a schedule, that's usually a requirement that was set forth by the SEC or different banking so that people know how much is going to interest or and principal. So keep that in mind. Amortization schedule and amortization schedule for a $33,000 6.5% loan that requires 3 equal annual payments. Okay, so $15,000 R equals 6%, so our payment is going to, so we're trying to calculate how much our equal payments are going to be. Okay, so we're going to go, we have 3 equal payments, or our in is 3 years, 6.5%, 33,000. What we're trying to calculate is our equal payments with our interest. Okay, so future value is 0, so minus 12,460. So that's how much our payments will be. $12,460 equal payments. And here's our amortization schedule. Okay, payment $1,240. So 3 equals 1 times 0.065. Okay, so we get this value, $2,145. Okay, here's our repayment of principal. This is just our interest, by the way. Remaining balance is $22,685. Again, here's our equal payment. This is how much is going to interest. This is how much is going to principal. And the remaining balance is $1169. Our payment is here again. This is how much goes to interest. By the way, this is very true on your car payments and your house payments. If you have a mortgage, your interest starts to decrease and your principal starts to increase as that decreases. Okay?